We turn now to the asteroid being called a city killer. There's a chance it could hit Earth.
In a startling and alarming development, NASA has revealed that the probability of a recently discovered asteroid colliding with Earth has doubled, sparking widespread concern among scientists and the public alike. This update follows a series of crucial observations, refined calculations, and newly gathered data that have significantly altered predictions about the asteroid's path. Asteroids have long posed a potential threat. These colossal space rocks, sometimes spanning hundreds or even thousands of meters, hurtle through space at immense speeds. When their trajectories intersect with Earth's orbit, they have the potential to cause devastating impacts, keeping organizations like NASA on constant alert. However, up until recently, the asteroid in question had seemed to be just another object in space, potentially dangerous but not an immediate threat. But now, NASA has reported that the likelihood of it striking Earth has increased dramatically, and that has the global scientific community on high alert. So, what exactly happened to cause this sharp increase in the chances of a collision? How did astronomers come to this alarming conclusion? And what are the potential consequences if the asteroid does indeed make contact with Earth? Let's take a closer look at the situation, break down the science behind it, and explore the steps NASA is taking to monitor and mitigate this growing threat. The asteroid, designated 2025 XG, was first discovered several years ago. Initially spotted by amateur astronomers as part of a global initiative to identify potentially hazardous space objects, it was originally considered just another ordinary asteroid among the many that share Earth's orbital neighborhood. Early assessments suggested it posed little threat, with scientists believing it was unlikely to come close enough to cause significant concern. However, as NASA's telescopes continued to track it, a clearer understanding emerged. Precise observations allowed astronomers to refine its orbital path, revealing that while it was not on a direct collision course, it was gradually drawing nearer to Earth each year. Monitoring and tracking near-Earth objects and NEOs, like this one, is crucial for assessing potential risks and understanding their long-term impact on our planet. NASA and other space agencies around the world have invested heavily in tracking these objects using advanced telescopes and space probes, with the goal of identifying any threats that could pose a danger to Earth. But despite years of monitoring, there were still many uncertainties about 2025 XG's trajectory. While early estimates suggested that it had a relatively low chance of striking Earth, astronomers couldn't be completely sure. These objects are difficult to predict, and their orbits can be influenced by a variety of factors: gravitational pulls from other planets, the sun's radiation, and even the slight pressure exerted by sunlight itself can alter an asteroid's path in unpredictable ways. The key challenge for scientists has always been the limited data available in the early stages of an asteroid's observation. The more time that passes, the more accurate the predictions become, and that's where the recent shift in predictions comes into play. How did we move from what seemed like a low-risk scenario to a sudden doubling of the impact probability? The answer lies in updated data, improved technology, and refined calculations based on recent observations. First, let's explore the impact of gravitational interactions. As 2025 XG orbits the Sun, it experiences gravitational influences from nearby planets, particularly Jupiter and Mars. Even minor gravitational nudges can subtly alter the asteroid's trajectory, changes that may not be immediately noticeable but can accumulate over time. Recently, astronomers observed that Mars' gravitational pull had slightly shifted 2025 XG's path. Though initially small, this deviation significantly increased the asteroid's chances of colliding with Earth in the coming decades. As it continues its orbit, further gravitational interactions could cause even more pronounced shifts, raising the likelihood of a future Earth-crossing trajectory. Additionally, advancements in observational techniques have provided a more precise understanding of the asteroid's size and rotation. While early estimates suggested that 2025 XG was relatively small, possibly only a few hundred meters wide, new data indicates that it could be larger and denser than previously thought. Scientists have discovered that the asteroid is denser than previously thought, which changes how they calculate the impact energy of a potential collision. A larger, denser asteroid could cause significantly more damage if it were to hit Earth. Another key factor in the updated predictions is the advancement in orbital modeling technology. NASA and other space agencies have developed more sophisticated software tools that can simulate the paths of asteroids with much greater accuracy. These tools consider various factors, including gravitational interactions, solar radiation, and even the Yarkovsky effect, the way an asteroid's rotation and heat absorption can affect its trajectory. With these new modeling techniques, scientists have been able to make more precise predictions about the asteroid's future path. The updated calculations show that the asteroid now has a significantly higher chance of hitting Earth. In fact, recent estimates suggest that the probability of impact has increased from less than 1% to just over 2%, doubling the previous risk. While 2% might still seem like a small number, in the context of potential asteroid impacts, it's a major cause for concern. Even a small increase in the likelihood of a collision can have serious implications for global preparedness and response strategies. Now that we understand the likelihood of a strike has doubled, let's examine why NASA is particularly concerned. The primary issue isn't just the immediate threat of an asteroid impact. While a 2% probability remains relatively low, it's still significant enough to warrant attention. The real concern lies in the long-term consequences and unpredictability of the situation. First, there's the potential impact on Earth. Although the asteroid in question is small by cosmic standards, it is still large enough to cause considerable destruction if it were to collide with our planet. An impact of this magnitude could release energy equivalent to several hundred megatons of TNT, far exceeding the power of any nuclear weapon ever detonated. This level of force could lead to widespread devastation, particularly if it struck a highly populated area. The resulting impact could trigger massive earthquakes, tsunamis, and fires, depending on the location of the strike. A direct hit on a major city could result in tens of millions of casualties, while an ocean impact could generate a colossal tsunami, wreaking havoc on coastal regions. Even if the asteroid were to land in a remote area, the environmental consequences would still be severe. The collision would eject vast amounts of dust and debris into the atmosphere, potentially blocking sunlight and triggering a nuclear winter effect, causing a significant drop in global temperatures. In addition to potential physical destruction, there's also the issue of global preparedness. While space agencies like NASA have been tracking near-Earth objects for years, we have very few methods to prevent a major impact. Currently, no technology exists that could effectively deflect an asteroid from its path, and the window for action is incredibly short. NASA has been working on potential asteroid mitigation strategies, including using spacecraft to nudge asteroids off course, detonating nuclear devices near an asteroid to change its trajectory, or even using lasers to vaporize parts of the asteroid. However, all these methods are still experimental, and none have been proven to work on an asteroid of this size. NASA's concern also lies in the fact that we don't have much time. While the asteroid is not expected to strike for decades, the sudden increase in its impact probability means we may have less time to prepare than previously thought. A 2% chance may seem small, but when it comes to asteroids, it is still a significant risk, especially given the potential for catastrophic consequences. As the chances of a strike increase, NASA is intensifying its efforts to track and monitor the asteroid. The agency is utilizing a range of telescopes and radar systems to closely observe its trajectory and refine predictions as new data emerges. Scientists are also investigating innovative risk mitigation strategies, such as enhancing asteroid deflection techniques and formulating evacuation plans for potentially affected regions. Beyond NASA's initiatives, international space agencies, including the European Space Agency, ESA, and China Space Program, are working together to monitor the asteroid. This global collaboration is crucial to ensuring a swift and coordinated response if the likelihood of impact rises. Additionally, NASA is expanding its outreach efforts to keep governments and international organizations informed about the potential threat. Public awareness campaigns, educational initiatives, and emergency preparedness plans are all key components of a broader strategy to ensure humanity is equipped to handle any asteroid-related risks. As the possibility of a collision with asteroid 2025 XG looms larger, the need for global cooperation has never been more urgent. The threat posed by an asteroid impact is not an issue that any single nation or space agency can tackle alone. Given the global scale of its potential consequences, addressing and mitigating this risk requires a collaborative international effort. NASA, the European Space Agency (ESA), and other space organizations worldwide are now working more closely than ever to confront this growing challenge. A key aspect of these global efforts is the ongoing surveillance of 2025 XG. With uncertainties surrounding the asteroid trajectory, it is crucial for astronomers and space agencies to conduct more precise and intensive observations. By combining resources and leveraging some of the world's most advanced telescopes and space observatories, NASA and its international partners aim to track the asteroid with the highest level of accuracy possible. For example, the European Space Agency has partnered with NASA on a series of joint missions dedicated to studying and monitoring near-Earth objects, NEOs. This approach involves using multiple observatories to observe the asteroid from various vantage points, ensuring access to the most precise and up-to-date data. The more information gathered, the greater the likelihood of accurately predicting the asteroid's future path. Additionally, these space agencies are working closely with governments and world leaders to establish frameworks for responding to a potential impact. While the risk of a catastrophic strike remains low, it's important to remember that the asteroid may become a more imminent threat in the coming years. Preparing for such a scenario requires robust communication channels and the ability to coordinate efforts quickly and efficiently on a global scale. For example, NASA has been in talks with the United Nations to discuss asteroid threat preparedness. The United Nations Office for Outer Space Affairs, UNOOSA, has been working on developing guidelines and protocols for how nations should respond in the event of a potential asteroid impact. These discussions involve everything from possible evacuation plans to international cooperation in mitigating the risk. The focus is not only on monitoring and preparing, but also on enhancing the world's overall understanding of the asteroid impact threat. Public awareness campaigns are being launched to educate people about the dangers of asteroid impacts and the measures that are being taken to protect humanity. These campaigns aim to inform individuals about the science behind asteroid threats and to demystify the work being done by scientists and space agencies. The more people understand the situation, the more likely it is that governments will take the necessary steps to ensure global security. The role of space-based defense. How can we prevent an asteroid impact? While monitoring and preparedness are crucial, the key question remains: what actions can we take if an asteroid truly threatens Earth? At present, there is no guaranteed method to deflect or destroy an asteroid, but several promising technologies and strategies are being explored that could, in theory, avert a catastrophic collision. Leading these efforts is NASA's Planetary Defense Coordination Office, PDCO, which was established to safeguard Earth from potential asteroid threats. The office is actively developing and testing various mitigation strategies to ensure we are prepared to deflect or alter an asteroid's trajectory if necessary. As the probability of asteroid 2025 XG impacting Earth continues to shift, scientists and space agencies remain dedicated to monitoring the situation, advancing deflection technologies, and ensuring humanity is ready for any scenario. Although the immediate risk of collision remains low, the increased likelihood serves as a stark reminder of our planet's vulnerability to cosmic threats. The coming decades will be crucial for refining technologies and strategies to prevent a devastating impact. Through global cooperation, AI-driven detection systems, and emerging deflection methods, humanity may eventually possess the means to shield Earth from this existential danger. Until then, the threat persists, and the world must remain vigilant and united in its efforts to prepare for the unknown.